Hey, Mark.
Hey, Dave.
How are you today?
Good.
All right. Looks like you're reviewing all of the circle theorems here.
Yeah.
All right. One way I like to remember is if these lines that are crossing inside or outside of the circle, if they intersect outside the circle, then I'm taking the difference of the arcs.
Yeah.
If they intersect inside the circle, I'm taking the sum of the arcs. Every theorem I know where they intersect outside the circle, you take the difference of the arcs. And every theorem that I know where you're inside the circle, you either take the sum or multiply the segments. So,
Okay.
I notice you've done number 20, but let's do it again. Let's set it up properly. Always,
All right.
I mean, I'm not sure why almost every student I have does it the way you did it here. But here's what the theorem says. If you have two intersecting arcs that don't intersect at the center, that's not at the center of the circle, well then that angle, which is the same as its vertical angle, 150, let's start with that in our equation. It's half, because all of these are half, but it's half of the sum of the arcs, meaning it's the average of these two arcs. Well, how would you find the average? You would take them, add them together, and divide by 2. So it's half of 105 plus x. That's the equation you want to write.
Okay.
I know you've written that. You've reversed it, and that's fine. You know, I'm not picky. I just think that you should always start with the general formula as the book gives it. Okay? The book gave you theta is equal to 1/2 of the two arcs added together. That's the way the book gave you that theorem. So when you run into a problem, make sure you write it in that manner. It's easier to do if you always write it in the manner of the general equation. Now once we've written it, it's really easy to solve. You can multiply both sides by 2, which is what you did. Only thing is, you got to be a little careful here. In other words, that equation is not correct. You've multiplied the left side by 2, but you didn't multiply the right side by 2. So if I'm really going to multiply by 2 as my first step, then the next equation is 230 equals 105 plus x. Now x equals 125. And notice that 115 is the average between 105 and 125. It's exactly halfway in between those two numbers. But I still think it's important to set it up right. Set it up by the way the equation, the theorem is defined. It'll be easier to memorize it. Now, when you have the following situation, it looks like what they're doing here is almost giving you every combination. Call that angle 1. Call this arc 234.
Okay.
What is arc BC? Oh, excuse me. What is minor arc? Well, what is arc BCA? Measurement of arc BCA.
Is that 1?
Well, that's angle 1. That's what we're trying to solve for. But in order to solve for this angle, we got to solve for this arc.
Oh, that's 360 minus 234.
126. It's 360 minus 234. Okay. Now we have the measurement of arc BCA. Now, what is this angle 1 right there?
63 degrees.
Correct. And it's half. Here's the reason we know it's got to be half. What do these two arc measurements add to?
360.
What do these two angles add to?
360.
No. These are linear angles.
Oh, 180.
180. Well, notice that angle 1 intersects arc BCA. Angle 2 intersects arc BA. So, therefore, the formula has to be half. In other words, I know that angle 1 has to be half of the arc that it intercepts, just like most of the equations are, is half. And angle 2 has to be half of the arc that it intercepts. The reason we know that is because these two arcs we can see add to 360, and we know the angles add to 180, so it's got to be a 1/2 relationship. It can't be a 1-to-1 or a 2-to-1 even. It's got to be half. Let's look at number 22. is really kind of the most common situation you have with these circles. You have two secant lines intersecting outside of the circle. Okay, this is angle 1, and that's what they're trying to solve for. Put some labels on this. Tell me what angle 1 is by the general formula.
1 is 85.
No, tell me the general formula. What is angle 1 equal to? 1/2 of something.
1/2 85 plus
don't give me numbers. Yeah, give me letters. In other words, I want to make sure you understand the concept before we stick numbers in there.
1/2 AB plus CD.
Minus. Because the intersection is outside of the circle.
Okay.
Okay? When it was question number 20, the intersection is inside of the circle. So I'm adding those arcs. But every time it's outside the circle, it's going to be half of the difference of those two arcs. So now let's put numbers on it. This arc is, let's see, the big arc is 85. The little arc, they don't give us, but they give us this as 95, and they give us this as 175. Can we figure out the little arc?
Yeah.
CD.
5.
What is CD?
5.
Good. Now we got everything we need. Angle 1 is equal to 1/2 85 minus 5. 1/2 80, 40 degrees, correct. But this picture and this general formula applies no matter whether they're secant lines or tangent lines. In other words, it's going to apply on question 27 exactly the same. This angle, well, question 27 is a different question because now they're not talking about arc measurements.
Yeah.
But my point, well, it applies on 23. But 23 is two secant lines intersecting outside the circle, right? So 23 is really the same as 22. There's no difference. Give me the equation that's going to apply for 23. How are we going to solve 23?
Okay. 39
Start
equals
good.
1/2 17x plus 6 minus 7x minus 2.
7x minus 2, and there's something very important we need to do there. We need to put parentheses around that.
Yeah.
And it matters. If we don't put parentheses, we're not going to get the right answer. Notice that by adding the parentheses, because we need to add it because this is the full arc that's being subtracted. But when we add those parentheses, that -2 turns into a +2. In other words, now we have 1/2 of 17x plus 6 minus 7x plus 2. So by adding the parentheses, we got the correct sign on this +2. So without the parentheses, we're getting the wrong sign on it, and we're missing the problem. So very, very important set of parentheses to add. In fact, frequently when you're subtracting a quantity, this time we're subtracting the quantity 7x minus 2, always add the parentheses for clarification if nothing else.
Okay.
Okay? It's better to have too many parentheses than too few. A lot of times I'll add parentheses in the front where I know they're not needed, but I add them merely because it's clearer. Okay, problem 20 was two intersecting chords inside of a circle, but it had everything to do with angles and arc measurements. Question 24 is two chords intersecting inside of a circle, but this has everything to do with segment lengths. Completely different. This is all about degrees. This is all about measurement of the length. They want us to know what that length is. Well, what's the general formula that applies here?
A times B equals C times D.
Yeah, or 8 times 3 equals x times 6. In other words, one segment times the other segment is equal to one segment times the other segment. It's very straightforward, very simple. You're not ever going to get it wrong. Okay? Remember, that's only when you're inside the circle.
Yeah.
Now let's look at 25. 25, we're outside the circle, and it's not the same equation. In other words, you might be tempted to say that 3 times 3 is equal to x times 8. Not true. It's true that we're going to take 3 squared, but it's equal to the segment that's outside the circle, that's x, times the entire length of the secant line, which is what?
X plus 8.
Yeah, so that's the equation. Notice the difference. It's not x times 8. It's x times x plus 8. Completely different than when you're intersecting inside the circle. And now that becomes a quadratic because I now have this. And now I've got 0 equals x squared plus 8x minus 9. How do I factor that?
Whatever adds up to the first one and multiplies to the second.
Give me the two factors. There's 3 steps here. There's 4 steps. And I don't know why I have a hard time getting everybody to memorize these 4 steps. I guess it's because it's not the way they teach you in class. But if you always do my 4 steps, it's going to work every time, I guarantee you. Okay? Step 1, split the x squared up. That's step 1.
Okay.
Step 2, determine both signs. What do both signs have to be?
Huh?
determine the sign that goes in the middle of that linear term, both of them. That's step 2 for factoring.
Okay.
They have to be opposite. Notice that as long as I have a plus and a minus, no matter what numbers I put here, I'm going to produce a negative number. Because this term always comes by multiplying this number times this number. So working backwards, when you see that's negative 9, you know both of these signs have to be opposite. It might be minus here and plus there, but it's not plus plus and it's not minus minus. If it was minus minus, this would have to be a plus. Okay? So that's step 2, determine both signs. Notice that we're almost done with 2 very, very simple steps. Now, step 3, factors of that number that subtract because of that sign to the number 8. Well, what are factors of 9 that subtract to the number 8?
3.
Factors of 9. 2 numbers that multiply together to 9. Not 3 and 3, because 3 and 3 to subtract to 0.
6 and 3.
That's not factors of 9. About 9 and 1.
Okay.
Remember, we're looking for factors of 9 that subtract to the number 8. Well, we just found them. So that's step 3. Now, step 4 is you put the bigger of those factors with the sign of the middle term. The sign of the middle term is plus. So the 9's going here, the 1's going there, and it's factored.
Yeah.
That's the proper factoring for it. Okay? If you always use that technique for factoring, you will not have any problems. Now, I understand that this coefficient is not always 1. Sometimes it's 2, 3, 6, something other than 1. But 95% of the factoring problems that you're going to have, that you have to do, are going to be first level factoring problems. In other words, the x squared has always got a 1 in front of it.
Okay.
The harder ones are just that, harder. They're much harder to do, which means you're not going to be tested on them very often. You're going to be, this is it. If you use my 4 steps, you will never have any problem with factoring these. Now, granted, when you put numbers like that in there, now it becomes a significantly harder factoring problem, and it kind of turns into more of a trial and error question. But you don't see many of those. I would say 10% of the factoring problems you get are going to have a number in front of the x squared. 90% of them, it's going to be x squared. It's going to be something that looks just like this. So it's going to be really easy to factor if you use my method. All right, let's go to the next problem. 26. Now, notice that all these circle problems are similar. We're either solving for arc lengths, or angles, or measurements of arcs, or measurements of segments. And it's important to distinguish between the 2 types of problems. In problem 20, we were solving for the measurement of an arc, okay? We weren't solving for the length of anything. In problem 24, we were solving for the length of this segment, x. It didn't have anything to do with any of the angles in 24. And all of these problems come down to that. Either 22, we were solving for angles, and we had a bunch of arc measurements. Same thing with 23. We were given an angle, and we were solving for these arc measurements. 24, we were solving for a segment length. Same with 25. We were trying to solve for x. 26, we're solving for segment lengths. 26 is not the same kind of problem as 22 and 23. It's two secant lines that intersect outside the circle, but the formula for determining the size of the arc lengths is completely different. Let me label this so that we can talk about it. What's the formula that applies to each of these segment lengths?
A times AB equals D times DC.
Well, first of all, I added this E so that we could refer to this segment length as AE.
Okay.
So AE times what? Is it
EAB?
Not AB. That's the same formula as chords that intersect inside the circle. And this is not the same at all.
EAB.
This is more, it's EB. AE times full secant length equals ED times what?
EC.
Yeah. In other words, completely different than the chords. The chords, it's this segment times this segment equals this segment times this segment. This is much more complicated. This is this segment times the whole chord, or the whole secant line equals this segment times its entire secant line. So, what equation can I write from figure 26?
X times 8 equals 5 times x plus 1.
Not x times 8. It's x times the whole secant length. What's the secant length?
X plus 8.
Okay. Equals the part that's outside of the circle, which is x plus 1, times what?
Plus x, times x plus 1 plus 5.
Which is x plus 6. So now all we have to do is solve that equation. Well, there's only one variable in that equation. It's going to turn into a quadratic. But notice that it really doesn't turn into a quadratic, because the first thing you do is cancel those. Now if I move the 7x over, it turns into a really easy solution. So x has to be 6.
Okay.
And 27. Now, 27 is really the same formula as 26, if you think about it. It's the part of the secant line that's outside the circle times the entire secant line. So it's x minus 2 times x minus 2 plus x plus 2 equals, well, the right side of it, it is x squared, but if we forgot that, let's use the same terminology. It's the part of the secant line. This is a tangent line, but let's look at it as a secant line. It's the part that's outside the circle times the whole thing. Well, the whole thing is x, right?
Mm-hmm.
So that's why it's x squared. But it's the same general formula as 26. It's the part that's outside the circle times the whole thing equals the part outside the circle times the whole thing. Well, just pretend this tangent line is a secant line. And then the part that's outside the circle is x, but the whole thing is x. So it's x times x, and that's where you get the x squared. And then this simplifies those 2's cancel, and you end up with 2x times x minus 2 equals x squared. And now you do have a quadratic you're going to have to solve. But, so they really kind of covered 8 different types of circle problems with these 8 questions. This is really a good review. If you understand each of these 8, you should be in pretty good shape for any kind of test on circles. There may be a few other theorems involved, but I can't think of any. I think they covered all 8 theorems that were in the book with these 8 problems.
Mm-hmm.
And then 28 and 29 have to do with the equations of a circle, which unfortunately I don't have time to go over, but it looks like you understand those pretty good. Equations of a circle.
Yeah.
Minus 7 and plus 4 is the center, and the radius is square root of 2. That's correct. And this one you got x minus 1 plus y plus 3 equals 25. That's correct. And then graphing it's pretty easy if you know where the center is and you know what the radius is.
Yeah.
This is a good page. If you're proficient on this page, you're going to do good on the test.
All right.
Okay? All right, Mark.
Yep.
I will talk to you next time.
All right, Dave. Thank you.
All right.